Okay, couple review practice problems on logs. If I have log base 1 right away, no matter what I write next, it can't be right because you're not allowed to have a base 1. But I can even make it worse by putting that, log base 1 of -1. Now, that base is not an allowed base, and you can't have a negative in the argument. So this one's wrong on 2 counts, so it's no solution. Some people argue with the base 1 thing and say, well, but I could find a case that it'll work. If I make this an x and you say 1 to the x equals 5, you just can't make it work. The only exception is, I would admit, log base 1 of 1 seems like it would work, but since it's the only one that you could ever have work, then they don't allow 1 as a base. It's just one of those things that's not in its domain, it's called. All right, so enough about number 1. Number 2, if you're going to solve this, you would hopefully know that you want to put this 4 somewhere. I'm going to put it up here as a power on the argument. And then I'm going to say it's x plus 1, rewriting, to the 7th. And then I'm coming back to the 2 to the 4th. That's this to the this equals that. And then to solve it, I'm trying to get the x alone. I'm putting it to the 1/7 power. And then I would have these cancel, thankfully. X plus 1 equals 2 to the 4th to the 1/7. I have no idea. I think it's 1.49 if I remember correctly. Subtracting 1, x equals 0.49. There we go. All right, on to number 3. On number 3, my hint is that ln should be rewritten and made into log base e. And that way these bases are the same, and this becomes 2. 2 times 3 is 6. 4x plus 6 equals 14. And then from there, it's super easy. I believe that I ended up getting 4 on this one, but I will just show one last. That was the 12 minutes left alarm. Oh, x equaled 2. My bad. There we go. Okay. And now, this is a really tough one. If the blue one is a transformation of this, it starts as that, then we already figured out that a base log, the base log, this log base 2 of x would look like this green one. And then we figured out it must have been flipped like this black one. And then somehow it's moved up and over to make the final answer. Who thinks they have it now? And since you were the only one who had it from the beginning, let's see if you have it. Like that? Okay, now, how can we prove if he's right or wrong? You have an XY chart, and on the XY chart, best friend in graphing, you can take the 0, 1 and see if it actually works. Put a 0 here, and then, ooh, you won the argument. The argument part will equal 1. So this whole thing is 0, but then it's -0, which is still 0. Add 1, which makes it 1. Yay, the 1 point we have worked. What if there's multiple points? All the points would need to work in your equation. Okay. All right. So that's a pretty tough one. And how many of you, after a little help, got that one? Raise your hand if you got that one. Okay, good. Without the little help, though, nobody seemed to get it. I think it's because it's really, oh, maybe somebody did have it. I asked who thought they had it, and only one person raised their hand. Okay, so that's not an easy one, mostly because it's hard to see those reflections. All right, moving on. This last one is, sorry, not the last one. Number 6, I wanted 3 points and an asymptote for this. Well, that all comes down to smart things to plug in. And if you put in a 1 here, that's pretty smart. Why? Because this becomes a 2 and your bases match. And then that means it's equal to 1, and 4 times 1 would make it 4. Who had 1 comma 4 as one of your points? Awesome. Now I'm going to put in 2, not 2, because I tried 2 and it makes the argument 3, and log base 2 of 3 is not nice. But I could put in 3, and then I will get 4 here, and in 4 log base 2 of 4, because 4 is really 2 squared, that would become 8. Who had 3 comma 8? Awesome. And there's usually a fancy-dancy fraction one where you got to take this red one and somehow put in something that makes it 2 to the 2 to the negative 1 inside. Did anybody figure out what x you could put in that would make that into 1/2? Negative 1/2. Very good. If you put in a negative 1/2, this becomes 4 log base 2 of 1/2. And, sorry, log base 2 of 1/2. And that's the same as 2 to the negative 1. And so that's negative 4. 1/2 negative 4 would have been a good point. And who's got one more? There's usually one more. Yes. You put in 0 and then you won the argument, which means you get 0 times 4 is still 0. When you put in 0, you got 0, right? Awesome. And then where's the asymptote? The asymptote is, well, where is it in the first place? Remember, the log looks like that. And the asymptote's here, which is the y-axis, otherwise known as x equals 0. Did it get moved? Yeah, which way did this move it? Left 1. So then my asymptote is at negative 1. Negative 1 is the asymptote. And if you can't tell that from looking at the picture, at least you could look at this and say, what could I put in here that would make the argument 0? Okay, if you make the argument 0 by putting in a negative 1 right there, negative 1, then you're going to get the asymptote if the argument is 0. There's some kind of a good statement there about arguing over nothing. Makes you into an asymptote. I don't know. Anyway, let's move it on to number 7. And I know some of you were like, there's not much time left. That's okay, because you know what your homework is, and it's just the same review sheet except you're doing the odds. Remember to do it, because I am going to collect it. I'm going to drop in the Dropbox tomorrow. Okay. All right, so here's another one that we tried. 4 log base mr equals p. And I'm going to say, rewriting that, the 4 should go up here. It could have been divided by 4 on both sides, and it could have been a divide by 4 there, but I like it better when it's a power. M to the p is equal to r to the 4th. There was the rewrite. That to the that equaled that. Make sense to you? And again, if you had put the 4 as a divide by 4 right there, then it would have had a divide by 4 right there instead of over there. Okay, moving on to number 8. 2 log base 3 of x plus 2 is equal to 3. I recommend you use the SRS technique, which is simplify it, rewrite it, and then solve it. Simplifying, I'd like to put the 2 up there as a little power on that, or I could have divided both sides by 2. Either way works. Then I'm going to take 3 to the 3rd is equal to all that. X plus 2 to the 2nd. And now I'm going to put it to the power of 1/2. Power of 1/2 cancels. And I have 3 to the 3rd to the 1/2. That's 27, and then it's the square root of 27. I don't know exactly what that is. If you guys have a decimal for it, that's great. And then I'm going to add subtract 2 from both sides. And the x comes out to be whatever the square root of 27 minus 2 is. 3.1196. Anybody verify that? All right. Awesome. There's a whole bunch of logs practice. Question? We did just do a square root, but the problem is that since the other answer probably makes that come out to be negative, it would be an extraneous answer if there was another answer. Good call, though. Okay, tomorrow is the test for reals. No other homework for tonight other than finish that other worksheet. All right, good luck. That's all I have for you for tonight.